All right, hello, both Honors Algebra 1 and Algebra 1. We're going to go over our guided practice problems for 9.5a. Guided practice problems 1 through 5 will be for all of both classes. The very last problem, which will be number 5a, will be for Algebra 1 only. And I'll remind you when you get there so that if you're in College Prep Algebra 1, you'll know that you do not need to do that very last problem. Okay, so here we go. The first two problems, in guided practice 1 and 2, we're going to learn how to complete the square, what that means, and then we're going to write that completed square as the square of a binomial. Again, we'll find out what all that means as we work through guided practice 1 and 2. This is preparation work for learning how to solve our quadratic equations using yet a fourth technique beyond factoring, beyond taking the square root, beyond graphing. To solve our quadratic equations, we're learning how to complete the square to solve our quadratic equations. It's the fourth of 5 ways that we're learning how to solve quadratic equations. Okay, so here we go. On guided practice 1, in your book, it's going to show x squared plus 8x plus, and then in your book, it writes c, but I'm going to create a box. The box will be open at first. X squared plus 8x plus box. And we have to figure out what goes in that box to complete the square. We are creating what is called a perfect square trinomial that we'll be able to write as the square of a binomial. And this, once we figure out that we have a 16 that goes in the box, this will be our perfect square trinomial, and then we'll be able to rewrite that easily as the square of a binomial down here. Let's see how we do it. To figure out what goes in the box when we're completing the square, we cut the number that is in front of the x term, the coefficient on the x term, we're going to cut it in half. So that's a positive 8. So we're going to think in our head, what is positive 8 divided by 2? And that's positive 4. We're going to make sure we include the sign here. That will be important in our next step, that we have either a plus or a minus sign here. Once we've cut that 8 in half, and we have written down the positive 4, we're going to square that positive 4 and put it in the box, and that will complete the square. We have just built what is called a perfect square trinomial. Then our next job is to rewrite what we've just written here in square form. So using the using our x method, we can discover very easily that this x squared plus 8x plus 16 can be rewritten as x plus 4 times x plus 4. So if we FOIL it back, x times x is our x squared, our outside 4x, plus our inside 4x is our 8x, and our 4 times 4 is our 16. So I didn't draw my x because I really don't need to. All I have to do is notice this plus 4 here, and it's going to go in the end of both of my binomials here. And then I'm going to rewrite that, since it's the same binomial twice. I'm going to rewrite it in the form x plus 4 quantity squared. We're going to use this process in a few minutes to solve some quadratic equations. So guided practice 1 and guided practice 2 are just getting you familiar with completing the square, filling in the number that goes in the box, and then taking that expression and rewriting it in its binomial of square form. Guided practice 2, same exact process. So in guided practice 2, you are presented with x squared minus 12x plus box. And at first the box is open, and we need to figure out what needs to go in the box to complete the square. We're going to build another perfect square trinomial here. To figure out what goes in the box, the first thing we're going to do is we're going to take the coefficient on that x term, which is negative 12, cut it in half, divide it by 2, and that's negative 6. We're going to write that down. Then we're going to square that number. So we're going to figure out what is negative 6 quantity squared. It's 36. So whether we're squaring a positive or a negative number, we're always going to get a positive here, so that's always going to be a plus sign. Okay, here's our perfect square trinomial that we have just finished completing the square. Now we need to rewrite this perfect square trinomial in square form. So we're going to rewrite it using this minus 6. Both binomials, if we write it separately, will be x minus 6 times x minus 6. We pull that minus 6 down. And if we FOIL it back, we know we're right. X times x is x squared. Outside is negative 6x. Inside is negative 6x. Negative 6x plus negative 6x is negative 12x. And then negative 6 times negative 6 is positive 36. So we know that we have rewritten this x squared minus 12x plus 36 correctly as x minus 6 times x minus 6. And then I'm going to rewrite that in square form. So again, since this happens twice, this binomial, we can rewrite it as x minus 6 quantity squared. Okay, now we're going to use this technique of completing the square to solve a quadratic equation. So in example 2, we're asked to solve x squared minus 16x equals negative 15 by completing the square. This is actually a problem that would be much easier to solve by factoring it, but we're going to go ahead and use this new method just to get used to how we complete the square in order to solve a quadratic equation. Step number 1, rewrite this equation, but add a box that's open to start with, plus box on both sides of the equation. So we copied the x squared minus 16x plus an open box equals copy the negative 15 plus an open box. And recall that we need to always either add or subtract the same thing from both sides of the equation to keep it true. So if I figure out that I need to put a 64 in this box, I also have to put a 64 in this box to keep the equation true. How do I figure out what goes in this box? Well, I'm going to cut my coefficient on my x term in half. Negative 16 divided by 2 is negative 8. I'm going to square that negative 8, and that becomes 64. So that's why I'm adding 64 to both sides. Then I'm going to rewrite this perfect square trinomial as the square of a binomial here. So my perfect square trinomial becomes this square of a binomial. They mean the same thing. X squared minus 16x plus 64 is the same thing as x minus 8 quantity squared. To figure out what goes here, I'm going to always pull that number that I see here. It's either going to be plus or minus. I'm going to pull it right into my binomial squared. Then over here on the right-hand side, I'm working out negative 15 plus 64, and I get 49. Next step is to take the square root of both sides. That's what I'm doing here. That will give me x minus 8 is equal to positive or negative 7. And then I'm going to add 8 to both sides. That's going to give me x equals positive or negative 7 plus 8. Then I'm going to pull this apart into two separate expressions. So x is equal to the positive 7 plus 8, that's here, and then negative 7 plus 8, and that's what I've written here. And since 7 plus 8 is 15, and since negative 7 plus 8 is 1, there's the values of x. I didn't need to use a calculator at all in this one, since I didn't have any non-perfect squares to evaluate. Okay, guided practice 4 and 5, we're going to solve by completing the square, and we're going to round to the nearest hundredth if necessary. Guided practice 4 will be just like the last problem we worked. Here's the equation we're working with. The first thing is to open up a plus box on both sides so that we can complete the square. Of course, this box is open as we begin the problem. We have to figure out what goes in both of these boxes. To figure out what goes in here, we're going to cut that coefficient on our x term in half, or we're going to divide it by 2, which is the same thing. Negative 2 cut in half, or negative 2 divided by 2 is negative 1. We'll square that negative 1. Negative 1 squared is 1, and we're going to put it in both our boxes to keep our equation true. Then we're going to rewrite this perfect square trinomial in a different form. We're going to rewrite this perfect square trinomial as the square of a binomial. We pull this minus 1 down into the binomial that we're squaring, and now we've rewritten x squared minus 2x plus 1 as x minus 1 quantity squared, and that's equal to 3 plus 1 is 4. Then we take the square root of both sides. Of course, we're going to get a positive and a negative root when we take the square root of both sides. When we take the square root, we're going to get x minus 1 equals positive or negative 2. That's a perfect square. I don't need a calculator for that. Then we add 1 to both sides, and that'll give us x is equal to negative 2, positive or negative 2 plus 1. Then we're going to break this apart into two separate expressions. We're going to break it apart into 2 plus 1. There it is. Negative 2 plus 1. There it is. 2 plus 1 is 3, negative 2 plus 1 is negative 1, and that completes guided practice 4. Guided practice 5, again, college prep and honors, you'll both be working on this particular problem. So everyone on guided practice 5, here's how it works. Same as the other problems that we've already worked above. We're going to open up a box, plus box, both sides. Again, when we rewrite this equation here and put plus box, it will be open at first. We have to figure out what number is going to complete the square that we need to put here, and then whatever we add here, we have to add the same thing on the other side. To figure out what goes in this box, we're going to cut 10 exactly in half. 10 divided by 2 is the same thing as cutting 10 exactly in half, and it's positive. So 10 divided by 2 is a positive 5. Square that positive 5, and the result will be 25. That's what you put in both of those boxes. Then rewrite this perfect square trinomial as the square of a binomial. Bring that plus 5 down into your binomial here and square it. Over here, negative 8 plus 25 is 17. And now we need to take the square root of both sides. That's what we're doing here, getting a positive and a negative root. We'll be left with m plus 5 equals positive or negative root 17. Now we need to subtract 5 on both sides. That's going to give us m is equal to negative 5 plus or minus root 17. Notice I put the negative 5 first and the plus or minus root 17 last. Remember, the protocol here is that we want that radical at the end, so it can't be confused as to what is inside of that radical and what is outside. So that's why we're not putting the minus 5 over here where we could get confused as to whether or not the minus 5 would be in or out of the radical. The radical will be at the end here. We'll use our calculator at this point to figure out what the square root of 17 is to the nearest hundredth. It's 4.12. And then we're going to break this expression apart into two different pieces. We'll have negative 5 plus 4.12, negative 5 minus 4.12. That's just breaking this up into its two separate expressions. Then using our calculator, we'll find that m is negative 0.88 and negative 9.12. So we're going to key these expressions in separately to get these two different values. And I see I didn't box that up, so let me do that here so that we know we are done with this particular problem. There's our values. All right, the last problem here, Guided Practice 5A, is required for honors only. College prep, you can go ahead and turn the video off at this point, or if you're curious, you can watch it. But Guided Practice 5A is for honors class only. All right, so we're going to work this problem the same way as we've worked all the others on our students. The thing about this problem that's a little different is we're going to have some fractions involved, so it makes it slightly more complicated. So let's see what we do when we get fractions in these equations. First, we're going to take the equation we see here. We're going to put plus box, it will be open to start with. We have to figure out what number goes in that box. It will be a fraction in this case. To figure out what that fraction is, we're going to take our coefficient on our n term. It's a negative number. We're going to divide it by 2, so negative 5/2. We'll leave it in improper fraction form in order to square it. It'll make it easier that way. So negative 5 squared is positive 25 over 4. So this is a plus sign. This will always be a plus sign. Whether we square a positive or a negative number, we're always going to get a positive result. So put 25/4 in both boxes to add the same thing to both sides. Now rewrite this perfect square trinomial you just built in the square of the binomial form. Bring that negative 5/2 down into your binomial here that's squared. And on the right-hand side here, we're going to go ahead and rewrite negative 1 as negative 4/4, so we have like denominators, so we can add those two quantities together. Over here, I left the left-hand side alone, and here I am simplifying the right-hand side. Negative 4 plus 25 is 21, so 21/4 is the result of adding these two fractions. Now I take the square root of both sides. Of course, I'm going to get a positive and a negative root. Next step, I am rewriting the left-hand side as n minus 5/2. The square and square root cancel each other out. And then I'm going to add that 5/2 to both sides. That's what I'm doing here. And the result is n is equal to 5/2 plus or minus the square root of 21 over 4. Now, it is true that the square root of 4 is 2, but I'm not going to bother with simplifying it in that way. I'm just going to say, you know what, I'm going to put all of this in my calculator, 21 divided by 4, and then taking the square root of that. And that will give me 2.29 rounded to the nearest hundredth. So now I have 2.5 plus or minus 2.29. I've rewritten the 5/2 in decimal form just because I've written the square of 21/4 as a decimal. Just makes it easier to add and subtract those two numbers. Here I am breaking apart 2.5 plus or minus 2.29 in two separate expressions, and then using my calculator to help me work those out if I want to. These are easy enough actually to do without a calculator, but a calculator is fine here. So n will be equal to 4.79 and 0.21. All right, that concludes our guided practice problems for 9.5a. Please make sure this is in your lesson 9.5a guided practice section, and it's time for you to start working on the homework problems for this lesson. We'll see you next time.